Powerful collaborations, cutting-edge science, and curious minds coming together for a glimpse of the future. Stay tuned as we look at the latest updates on some of the most promising technology projects. Welcome to our podcast. I'm Peter Ballant from Technicon. Today we again look at the European Union H2020 project called LEDLUM, which pushes LED lighting to a more efficient and reliable level. What are the project goals and how do partners from across Europe ensure that these goals are achieved? Here to answer that question and more is project partner Dietmar Klien from Tridonic, which is a global provider of smart and efficient lighting solutions here in Austria. Then later, we speak with Paul McCloskey from the Tyndall National Institute, which is a European research center located in Ireland. He gives us the rundown on all partners working in LEDLUM and touches on how LEDLUM results can influence the consumer market. In other words, how does LEDLUM affect you? We were able to talk with both gentlemen as the LEDLUM project winds down with a technical meeting here in Austria. Let's go into the studio. Welcome to Technicon. Please introduce yourself and tell us where you come from.
Yeah, I'm Dietmar Klien. I'm from Tridonic, located in the western part of Austria, so close to the Lake of Constance. And we are doing business in professional LED lighting. And I'm from the department named Global Technology and Innovation. And we are looking forward for future opportunities, technical opportunities that can be implemented in our product segment, which covers LED drivers, LED modules, controls.
And this is exactly what the LEDLUM project is about, right? It's developing drivers for LED lighting.
Yeah, for sure. And especially the goals of LEDLUM are brand new or very important for our business. So getting smaller, getting more efficient, getting cheaper to enable our customers, the luminaire manufacturer, for new, fancy and high professional designs where, let me say, the design is dominated by the function and not maybe by bulky electronic components.
So is this the problem then? Is this the issue that LEDLUM addresses? It's that the drivers are just too, in many cases, too bulky, too big?
Yeah, in principle, no one want to have drivers. Everyone want to have only light. And okay, someone want to have fancy luminaires as a design object, but drivers are never welcome because this is an extra part which you have to place somewhere. Normally, they always try to hide it somewhere.
So a traditional LED light bulb then gets around this because it's a little bit larger. Is that the case? You can hide the driver inside there?
Yeah, because you have to hide the driver in the socket finally. So that's the reason why it not always fits one-to-one in each incandescent luminaire. So they have also the pressure to make it smaller. But it's also in our professional lighting, where we had also in the past drivers, so fluorescent drivers, for example, or HID drivers. We have now the challenge due to the new form factor of LEDs, which are completely a different design than fluorescent. Fluorescent is a long round stick, and LED can be designed as a flat panel or as a thin stripe. So you have a high flexibility regarding design of the light source itself. So the driver, there is no optimum design for the driver in principle. Sometimes a long linear driver is good, sometimes more a quadratic shaped driver or a round driver is good for a luminaire. But in principle, the best solution is always to have a extremely small driver which can be placed in each, design of luminaire.
Okay, and in LEDLUM, this project gathers experts like yourself together to build something or to make something. How is this working with people from across Europe? I mean, you can't obviously stand around a workbench to experiment or to show your work. You have to do this through teleconference and meetings. What is it like working in that environment?
Yeah, as an engineer, normally you prefer to work directly with the other engineers from university and all the other companies because a lot of new ideas and content develops by direct face-to-face work. But as you said, this is not possible. But we said, okay, setting up transparent goals and time plans that everyone knows, okay, who is working on what, make it easier to work, let me say, more or less on independent on different locations. We have additionally monthly telcos with the protocols in, and also we have technical meetings where we come together and discuss and plan the next steps. Without these personal meetings, I would say it would not be so fruitful and efficient, because the contact, the physical contact, and let me say that you have a real face on the other side, it's very important in this project. So beside development, it's also a little bit of traveling.
So you have the benefit of working globally with partners, but you give up some things like the face-to-face.
Absolutely.
But it sounds like you do have a lot of contact. For example, you're right now here with us in Austria for a technical meeting. What happens during a meeting like this?
It's, first of all, for sure, it's updates. So we share what was the progress since the last meeting. And as we come physical together, so we have the opportunity then to show really something. So it's not only a slideshow, something like that. It's really a discussion on, for example, physical demonstrators or working together on flip charts on topic. So after this update, then also these working phases are addressed, where hot topics are selected, defined, let me say, in a common brainstorming. And then the people work in mixed groups on these hot topics to define the next steps. So the big part is really the working on technical discussions, on planning of the next phase, not on detailed time planning and resource planning, but planning it on this with the focus to define which topics have to be addressed by which company, and into, let me say, with which focus point or goal. And then we have also a little bit socializing, which is also not unimportant. So I would say it's threefold, these meetings.
And this is very valuable for your portfolio also, to see what everyone else is doing. Yeah,
absolutely. It's an input beside the daily business. So this is also an advantage. You come out a little bit from the daily business. You see different things. You have new triggers. Yeah, this is, let me say, a very good side of these international projects.
And so the good news is LEDLUM is almost done, right? The project is almost complete.
Time-wise, we are shortly before the end. We have demonstrators that show what can be achieved. The goals are extremely challenging, so we come to an end, but we have also to see that some of these challenging goals can't be achieved fully, because it's a technology project, it's a research project. Research has also some risk regarding achieving the goals. So it has two sides. We have some running demonstrators, running prototypes. We are very confident to get really new input for all the partners by using findings from the partners to go on with further developments. But from my personal point of view, I have also to say, yes, it was not possible, for example, to achieve these goals 100%, because there were more than 90% size reduction and so on. And then during this project, which 3 years ago it started, you learned also, okay, what is possible, what is not possible. But I think also this is very useful and fruitful to see, yes, we looked at this topic and it is not possible now. Maybe in 3 years we can readdress some issues. And so for that, I'm happy with the situation because we have a clear output. We come to an end with a positive demonstrator and also some findings. Yes, for example, extreme high integration into power inductors or capacitors on silicon. Okay, this needs some time. Maybe we can readdress it in 3 years, 5 years. And then you can, let me say, move it also a little bit out of your head. You can say, okay, I look later to it, and now I can focus it to...
I think most people would look at this and say, well, wow, we need a follow-up to this project so we could really leverage everything we've learned in the past. How does that go with a project like this? Is this technology something that you can use then, or your company can use for further development?
Yes, in principle, each partner can use it. So the universities use their findings to, let me say, sell the intellectual property. The companies, we have also we have one company in which makes not LED drivers or components for LED. They make integrated capacitors, for example. They can use the learning regarding the process to produce such products for their general product portfolio. And the other companies like we as Tridonic, but also Nordic Power Converters and LED Group, which is a luminaire company, they will use the findings independently from each other, tailored to their product portfolios.
Okay. And I can't help but wonder, this is a project that is completed by different companies around Europe, but it's funded by the European Commission. Who is it that said in the beginning, hey, we should explore this technology, or this technology is worth funding, let's do it? Is this come from the industrial side?
I would say the government give the framework. So they give, let me say, the funding pot, and they define the big framework, the big topics. For example, yes, don't know, as I know, 10 million in Horizon 2020 for products in the area of photonics and lighting. And then we as a company, for example, we look for what is important for the future product. So also already in 2015, we had already an internal, let me say, prototype with higher switching frequency, but we had the learning, yes, it is too expensive. So we could shrink the size a little bit. We saw, somehow the technology pops up, but we saw it needs more than only the internal knowledge. Then you visit conferences, you try to see what is going on outside. And for example, in LEDLUM, this was the initial, let me say, trigger. So meeting at conferences, partners from university, they show something interesting. You see, there is a match between the focus of the university, for example, the Technical University of Denmark. And then it's like often in the coffee corner, you come together and then you say, okay, you have the knowledge, we have the use case, we have these problems. Do you think you can solve these topics or together? And then it started, let me say, at the conference contact. And then due to the network of the companies and the university, you try to find other partners because you have to have a certain number of European partners. And then, you talk with them and then you hear, they have the same topics. And then together you try to define a common goal. And with this, you go to the European Union. So I would say it often, let me say, starts with personal contacts again. Mostly at conferences where you have the exchange, or sometimes also at research portals where you see that the university is active in this. It's more difficult to build. So in our case, it was not a direct contact between the business, between the companies, because it's also difficult in projects like that a partner in the project is a competitor of your company. So in our case, let me say the university was the kind of glue to bring the different partners together.
Well, this makes for an interesting dynamic, I can imagine.
Absolutely.
Okay. Well, I want to say thank you for taking the time today from your meeting. We'll let you get back to work with your colleagues. But thank you for coming down a little bit and sharing information about LEDLUM, which is an interesting project that I think on some level will touch everyone, whether you're a consumer or in the industrial sector. It's something that's really important for everyone. So thanks for your efforts in this project, and we wish you much success in the rest of the project.
Yeah, it was a pleasure. Thank you very much. Yeah.
Next up in the studio, we are joined by Paul McCloskey from the Tyndall National Institute in Cork, Ireland. Tyndall is one project partner among many. First of all, welcome, and tell us a little bit about the problem that LEDLUM is trying to solve.
Okay, so LEDLUM, what we're trying to do is improve LED lighting. So the LEDs themselves have shown remarkable improvement over the years in terms of the efficiency with which they can produce light for the given current and in terms of reliability. But the LEDs in general are supplied with a DC voltage, and so what you need is a power converter to convert the AC voltage, the mains voltage, to the DC voltage. And this is an area that has lagged behind because the converters are quite bulky and they also can be somewhat unreliable. So despite the LEDs having a very high reliability, the part of the piece that's likely to fail first is actually the converter.
Okay, so we could say LED lighting is really cool, but there's a problem.
This consortium is aiming to solve that problem.
Okay, and you mentioned consortium. This means that this is a team of people from everywhere. Could you talk a little bit about this team?
Okay, so I mean, I think it's a very good consortium because it puts together all the right members to achieve the goal. Starting with the end product, which is the luminaire, the actual LED light fitting. We have a company, LED Group, which is a company based in Ireland. And that's what they do. They produce LED lighting. We also, within the consortium, have Tridonic, which is one of the major suppliers of the power supply, which it's quite often called an LED driver. Then within the consortium, we also have, ourselves, Tyndall, and what we are doing is our interest is really the miniaturization of magnetic components. So one of the things that we're doing within LEDLUM is actually going to higher switching frequencies, which makes the passive components get smaller. And we in Tyndall are actually interested in making magnetics go right onto the chip, so make it integrated onto the chip. We also within the consortium have a company called Murata, which is a Japanese company. Their area is integrated capacitors, so that's the other side of the passives that need to go into the converter. So they're working on the integrated capacitor side of things. And then, of course, we have the project coordinated by Technikon. There's a company, NPC, Nordic Power Converters, and they're actually a company that specializes in very high frequency power converters. And it's a spin out from the Danish Technical University, which is also a participant within the project. And what DTU do is really they do a lot of the power electronics design, right, along with NPC. So, as I say, it's a good mixture of participants that have the right skills to bring things together.
And with this great team that you mentioned, what have you done so far? Or is there anything at this point that is tangible, or what are you proud of?
Well, I mean, I suppose we're on a path, right? And, I suppose what we're looking at is how to bring all the things together to make the final demonstrators. And in fact, the way we've ended up dividing the project is we have a development path and a research path. And basically, the development path is bringing together the technologies that are commercially available or close to being commercially available and using those to produce a demonstrator that is not very far away from being an actual product. And then within the research path, we're actually broadening the search in terms of the technologies. And so we can use technologies that are not quite commercially available. So we can aim to achieve more in terms of size reduction or cost reduction by using these technologies, but they're not as close to a product.
So me as a consumer, I walk into a store, wow, what do I see that could be a possible result of the advances that were developed in LEDLUM?
I suppose what you would see is a luminaire, which is more just the LEDs, and the driver for the LED has now got so small that it's maybe disappeared into the fitting. That's the sort of ultimate thing. And what you don't see when you walk into the shop is that the reliability of that has been improved, right? So that it'll actually last considerably longer. We're saying maybe by a factor of 2.
Okay, so part of your goal is to make everything smaller and more reliable.
More reliable, yes.
How about surprises? Did you encounter anything that was unexpected during the course of this project?
Well, I suppose one thing, we didn't really start off deciding to have a development program and a research program. Within this type of thing, there can be a certain tension, if you say, right. So, like we've got the end user LED group, and they're naturally very product focused. They want a product, and they want to know, what's the bill of materials, how much is it going to cost, and what features is it going to offer, which is perfectly reasonable. And then we've got also within the team, we've got DTU and ourselves, which are more academically focused. And I suppose, we're interested in contributing to the development path, but we want to really try and push as far as we possibly can in terms of innovative technology. And I suppose, as I say, we didn't start out with a plan of having 2 tracks, but it ended up being something that we arrived at as being a way of, accommodating both needs. And I think it's quite a good solution, and one which the project officer was quite happy to see, so.
Okay, so lesson learned, I guess.
Yes. Yeah.
Okay. I just wanted to say thank you for taking the time. I know you're busy with your team working to complete some certain tasks at this technical meeting. So thank you for taking the time and sharing your views of the LEDLUM project, and we wish you success. We know it will be busy, but it sounds like things are well underway, and the team's working well together. So congratulations for coming this far, and we're looking forward to see how things come out in the end.
So thank you for the opportunity to describe this project.
This podcast has been brought to you by Technicon. The LEDLUM project has received funding from the European Union's Horizon 2020 Research and Innovation Program under grant agreement number 731466.